In this video, I want to talk about binomial probabilities. Binomial probabilities are used when the possible responses are one of two options. All right, so like yes and no questions. So the formula we use is down here. The probability of x is equal to, now this thing here is n choose x, okay? And it's a specific function. We talked about the formula in class, or you can use the n choose x button on your calculator. And it's multiplied by p to the power of x times q to the power of n minus x. Now over here I've listed what n, x, p, and q are. N is the total number of identical trials. X is the number of trials for a specific outcome. So either the yes or the no, or the success or the failure. P is the probability of success. And often we know this probability of success by some sort of historical information, like last year's data for a team, and maybe we're basing the information, what we're trying to figure out on last year's information. Okay, so some sort of historical data we use as probability of success. This has to be a given. And then Q is the probability of failure, and P plus Q add up to 1. So, for example, if the probability of success is, say, 80%, then Q must be 20%, okay? Put those as a decimal, 0.8 plus 0.2 is equal to 1. So you're going to be given P probably, and you just need to figure out Q by knowing that the two of them as a decimal add up to 1. So in this example, we've got 14 people are asked if they own an electric vehicle. So that's a question that you would answer yes or no to. And based on past surveys, 10% of people respond yes to owning an electric vehicle. Find the probability that exactly 4 of those 14 people respond yes to this question. So let's determine what our values are. For this equation, we need to know n, and we want to know x, and p, and q. So n is the total number of identical trials. 14 people are asked the same question, so that's going to be 14. We want to know a success in our case is answering yes. The probability that exactly 4 respond yes. So that'll be a 4. And in this case, it's only 4 because it's exactly. That's important. Want to note the wording on that because in the next example, I'll show you some different wording. Now, the probability of success is given at 10%. So that's 10%. We'll put that as a decimal, 0.1. That means that the probability of failure is 90%, which is 0.9. All right, so we're ready to go with the formula. Let's fill in. The probability of exactly 4 is equal to n choose x. So 14 choose 4. We will use the calculator for that value. You can also use a formula that I provided in class. And then we've got probability of success, 0.1 to the power of x, which is 4. And the probability of failure to the power of n minus x, 14 minus 4. All right. So one little double check you can do is that those two exponents should, when they are added up, should equal n, right? And they do. 4 plus 10 is 14. Great. So let's see. And choose x. Let's grab the calculator. Put that off to the side. All right. We're going to use the NCR, which in this calculator is the second function of 5. So have a look on your own and see if you've got that and where it is. You enter the n value first, 14. And then you do that function button, NCR. They use R on the calculator. It's actually x in this formula, but that's for the same value. And then you want to enter your X value. So notice I've got here 14C4. That's 14, choose 4, which is this notation right here. And 14, choose 4 equals 1001. Okay, and 0.1 to the power of 4, 0.1 to the power of 4, 0.0001, and 0.9 to the power of 10. Now this one I'm going to have to do some rounding out. I'd like my final answer to go about 3 decimal places. So maybe we'll take this 4 or 5. Don't round it too much yet. So let's put it at 0.34868. If you don't want to round, just leave it on the calculator like this. Multiply by the other values, 0.1 to the 4. And then times 1001. And we get 0.0349. 0.0349. So that as a percentage is 3.49%. Okay, roughly 3.5%. Okay, I apologize for my phone ringing there. So that's a binomial probability. Now, one of the things I want to show you is that we could have maybe gotten this value from table 2. So let's take a look at table 2 together. Okay, I hope you can see this okay on your screen. I've zoomed in as much as I can to show you everything, but if not, open up table 2 and find the page where n equals 14, that's our n, x equals 4, that's our value, and we could use the table for this one because a p-value of 10% or 0.1 is actually in the table. If I gave you, say, 15%, 0.15, you wouldn't be able to use the table for this because it's not in the table. So you want to be able to also use the formula. But let me show you how. If we use the table and we go down to our p-value of 0.1 matched up with n equals 14 and x equals 4, 0.35 or 3.5%. Okay, so that's how you can use a table as well, but it only works if you are given a p-value that is one of these ones across the top. So here's another example, very similar, except we're finding out something a little bit different. Again, 14 people are asked if they own an electric vehicle, so n equals 14. Based on past surveys, 10% of people respond yes to owning an electric vehicle, so P equals 0.1, Q equals 0.9. Now, find the probability that no more than 2 people respond yes. No more than 2 people. Well, what is no more than 2 people out of 14 people? No more than 2. Can 2 be no more than 2? Yes. All right. So we've got X value of 0 people is no more than 2. 1 person is no more than 2. And 2 people are no more than 2. But 3 is more than 2. All right. So we're going to have to find out the probability of no more than 2 is equal to the probability that 0 answer yes plus the probability that 1 answers yes plus the probability that 2 answer yes. Okay. So you could do this with the formula for each one and add it up. We could also do it with the table, okay? So here's what I'm going to do, just to save a little bit of time in the video, is I'm going to write out what we would put for the formula for P of 0, P of 1, and P of 2. I'll come back on after I write it, and we will also take a look at the table to see those exact values. After calculating those values, we get P of 0 is 0.229, P of 1 is 0.356, and P of 2 is 0.257. Adding those all together is 0.842 or 84.2%. Next, we'll just take a look at those values in Table 2. So here are those same values in Table 2. If we go at n value 14, and x is 0, 1, and 2, and over to a p-value of 0.1 or 10%, 0.229, 0.356, 0.257. We would add those all up to get the same total probability that we did with the formula, okay? So there's a couple of examples on using this binomial probability formula, either using the formula or when you have one of these p-values, you can use the table. Okay, hope that's helpful. Thanks for watching.